So I'm Jay. I'm a PhD student at SRUC. I work primarily in work package 6, but I'm going to talk about some work we did in the stakeholder engagement part of work package 1. So many of you will remember that last year we undertook a survey with some general questions on attitudes and barriers to more appropriate breeding objectives, some questions on management interventions to promote resilience and efficiency. But the backbone of the survey was choice tasks, which I'm going to give more details on in a second. And last year, you'll probably also remember that we presented some preliminary results. Since then, we've had some more time with the data, and we found some inconsistencies in our analysis of the choice data from last year. So I want to start by asking you to forget the previous results of the choice experiment that were presented last year, and I'll now go through the improved results. So, like I said, one of the objectives of this study was to evaluate the relative importance of a set of traits given two different breeding goals, efficiency and resilience. We disseminated the survey using a snowball sampling approach, starting with partners and stakeholders within GenTORE, and many of you helped out with getting the survey out there. The traits for each beef, cattle and dairy cattle are shown on this slide, and they were chosen with a combination of literature review, earlier stakeholder engagement exercise, and discussion on the GenTORE e-platform. And next slide, please. So I just want to quickly describe the format of the questions. Some of you will remember the traits are down the middle, and respondents in each of 14 choice tasks were given a subset of 4 out of the 8 traits. They were given the general trait group, the specific trait, and a response to selection that is theoretically possible given 10 years of selection on that trait, ignoring genetic correlations. We calculated this response to selection for the most part using a breeder's equation with parameters taken from the literature and corrected for the Balmer effect. And the reason for this was to give respondents some idea of the possible gain for each trait. And this was primarily to ensure that everyone was on the same page when making choices and that respondents were not imagining vastly different levels of improvement. Next slide, please. So we had 200 people complete the survey. But after we filtered our surveys with missing this on the choice tasks, we were left with 85 responses in the dairy context and 38 in the beef context. So I'm going to focus mostly on the analysis of the dairy responses now because we had the greatest number of responses there, but I will come back to the beef results at the end. So when I'm talking about the results, unless I say explicitly it is for the beef results, then I am talking about the dairy responses. So these are the responding characteristics for the dairy. You can see in bold at the bottom of the table that respondents were mostly male, mostly middle-aged, mostly highly experienced in their profession. And you can also see that environmental issues were on aggregate perceived to present a greater challenge to dairy systems than economic or social challenges. Next slide, please. So onto the analysis of the choice data. So with this specific type of conjoint experiment, there are 2 types of analysis. Last year, we presented the incorrect results of the mean best worst analysis only. So this year, I'm going to go through the correct results of the mean best worst and then discuss some further analysis we did using Latent Class. So put simply, mean best worst is a counting approach which takes the mean of the number of times the trait is selected as best minus the number of times the trait is selected as worst. And with this approach, heterogeneity can be dealt with using a priori assumptions on drivers of preference, such as where a respondent's from. But this is limiting and often isn't as useful as more advanced approaches that deal better with heterogeneity. But it is useful to get a first look at the data, and at an aggregate level, if we weren't interested in heterogeneity, the results do correlate well with those more advanced methods like the logit models. And the correlation here is displayed in a plot. Each point is a trait, and you can see the correlation is very high between the mean best worst score and the multinomial and random parameters logit estimates. So the Latent Class analysis is more advanced. It's an extension of the multinomial logit approach, and importantly, it assumes discrete preference structures exist and that respondents can be grouped according to similarities in the preference structure. So in this approach, membership to one class of preference structure or another is driven by some underlying unquantified factor. So we don't need these a priori assumptions on drivers of preference. So I'm going to present the results in this order now. So next slide, please. So you can see here the traits are along the horizontal axis. Remember, we're talking about dairy here, and the mean best worst score is on the vertical axis. You can see that respondents are split according to the a priori assumption that a substantial driver of preference here is the region for which respondents were thinking about when making choices. So you can see that we have respondents split into alpine, Atlantic, continental, northern, southern, and not stated. You can see here that the differences in mean best worst, there is differences in the mean best worst score for traits between the efficiency and resilience contexts. That's most obvious for the milk protein trait there, the first trait. And you can also see that there are similarities between regions, which we confirmed with some follow-up analysis. And this made us think that if preferences aren't being primarily driven by region, then what? So next slide, please. So this is where latent class analysis is useful in that we find these discrete preference classes without any assumptions on drivers. So we take the aggregate data and we try to find a set of preference classes that can describe the choices made by all respondents. And one of the most important steps in latent class analysis is to find an optimal number of preference classes. So the number of classes in the model is selected according to the model fit, the interpretability of the classes, and the class sizes. So you can see here, this is the model fit for the efficiency classes. We chose a 3-class model in the end, but you can see that there's still some improvement in fit beyond the 3-class model. But when we kind of had a look at what was happening with these classes, we found that the 6-class model was just splitting the variation in a 3-class model, and the 12-class model was just splitting the variation in the 6-class model. So, and it wasn't really adding anything new in terms of differences in overall preference structure. So in terms, so we chose the 3-class model because it was the most parsimonious, I guess. Next slide, please. So if you imagine that everyone's trait preferences in the context of efficient production can be described well by one of these 3 preference structures, you can see the traits up the vertical axes, and the ratio scale probability is a transformation of the log estimates that makes them much easier to interpret. And you can interpret them as for class 1. Here you can see that milk protein can be interpreted as being 19 times more likely to be selected as best than emissions. In general, you can see from the classes that in class 1, longevity, RFI, milk, and disease resistance are the most important traits. For class 2, emissions is much more important, but at the expense of longevity and disease. And for class 3, milk production is very important, and interestingly, longevity is a joint least important trait. We also chose the 3-class model for similar reasons for the resilience context. That's the next slide, please, Harriet. And you can see here that for class 1, longevity, health, and heat are the most important traits. For class 2, there's a big focus on longevity and health. And for class 3, health is the most important, but slightly more balanced across longevity, RFI, and heat. And this is only the only class for the resilience classes where milk and emissions are even slightly important to people. Sorry, Harriet, do you mind going back? Yeah, and then if you don't mind flicking between the previous slide and this one, just while I say that kind of overall between the efficiency and the resilience classes, you can see that milk protein is less important in terms of resilience in people's perceptions. Longevity is generally more important, RFI is generally less important, disease is generally more important, and tolerance to heat stress is generally more important. So now I'm going to switch to the beef results. So just one more. Yeah, thank you. So we estimated these slightly different because latent class analysis wasn't really appropriate for the small number of responses. So here we used a mixed logit model, which in essence is similar to the underlying model of the latent class approach, but it assumes a continuous distribution of preferences rather than discrete preference classes. So you'll see here that there is just one preference structure for the efficiency context and one for the resilience context, and you'll notice that the variance is mostly larger. However, in spite of this, there are still clear differences in the preferences between the two breeding goals, especially with average data gain, carbon difficulty, health and heat, but not with emissions. Next slide, please. So an important point to remember here is that despite the measure of preference intensity of each trait, it should still relate back to the trait improvements that were part of the original traces. So if you take a look at this table, in the first column, we have the theoretical improvement as a percentage of the trait mean. The second column is the ratio scale preference estimates for the dairy efficiency class 1 groups. That was the you'll remember the first one we seen. And then if we multiply these two columns, we get the third, which gives us an indication of how these relative preference intensities are split between the available improvement. I should mention here that RFI, for RFI, the percentage improvement possible, the percentage of the percentage improvement as the theoretical improvement as a percentage of the trait mean refers to a change in the DMI that would result from a change in the RFI. So you can see here that although milk protein and RFI were similarly preferred by members of this class, for whatever reason, maybe there is more variation in the population in terms of RFI or a difference in heritability of the traits, the improvement that these preference intensities relate to are not so similar. Next slide, please. I don't really have time to explain these plots, but basically a useful thing about the latent class approach is that for each respondent, we get a probability of them belonging to each class. And if the model is a good fit, these probabilities are very high. And this was the case here. So it basically means that we have the opportunity to treat class membership as a multinomial variable, and we can look at understanding how demographic and the attitude questions of the questionnaire relate to these different preference classes or drive memberships for the preference classes. It is likely that the class membership will link better with attitudes than to demographic characteristics, and some preliminary analysis we've done in this respect confirms this. Yep. Next slide, please. I'm going to leave it there for time because everybody else has been so good keeping time. I don't want to be the one that overruns. So thanks to everybody that was involved in the distribution and response to the survey and for help with the translation and analysis. And thanks for listening.
Thanks, Jay.